Welcome to the Dream Architect channel. Today we will embark on a quiet journey into the forbidden corners of space, to the whispers that are usually drowned out by the thunder of great discoveries. We will look behind the scenes of official reports to where science touches upon mystery and human knowledge, the bottomless ocean of the unknown. These are not stories of conspiracies, but quiet admissions of how little we actually understand. These are stories of paradoxes, anomalies, and that unsettling beauty that is not usually spoken of aloud so as not to disturb our peace. We will be listening not to facts, but to the echo they leave in the soul. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. This helps others find their way here, one sleepy soul after another. And now, just breathe. Allow your eyes to grow heavy and your mind to become softer. Let us begin. There is a silence in space that is not merely the absence of sound, but is felt as something dense, oppressive, almost alive. It is not the peaceful silence written about in books, but a fundamental property of space that, it is said, drives one mad. Astronauts on spacewalks sometimes describe a feeling as if their own existence is dissolving in this primordial void, and their consciousness is expanding to unbearable limits. Their ears catch only the beat of their own heart and the sound of their breathing in. The spacesuit, but the mind hears the deafening roar of infinity. It is a reminder that the universe was not created for us, and its true voice is a silence that erases all meaning and lays bare our solitude. And in this all-consuming silence, sounds are sometimes born that have no place in a vacuum, where there is no medium for their propagation. Spacecraft like the Voyagers or the Juno probe capture not acoustic waves, but electromagnetic oscillations of plasma, which scientists can convert into sound audible to us. And what we hear resembles a choir of ghosts, drawn-out moans, a chilling whistle, crackling, and a deep hum emanating from the magnetospheres of the gas giants. These are the voices of Jupiter and Saturn, their invisible storms and auroras translated into a language understandable to our ear. These sounds carry no information, but they create a sense that giant, slumbering entities are breathing and whispering in the darkness, billions of kilometers away from us. This whispering sometimes takes the form of an almost meaningful signal, which then haunts scientists for decades. The WOW signal, detected by the Big Ear radio telescope in 1977, was exactly that, a powerful narrowband burst of radio waves lasting 72 seconds that came from the constellation Sagittarius and was never repeated. It precisely matched what we would expect from an extraterrestrial civilization trying to announce its presence. The astronomer Jerry Amen, who discovered it, circled the printout in red and wrote, "Wow," in the margin. But since then, silence. We have aimed. Dozens of telescopes there, but have never found the source. The signal remained a cosmic ghost, a lone exclamation in the void, which makes one wonder, was it a fluke, or did we simply miss the only call? Or perhaps that call was not for us, but merely an echo of an event that occurred in a world with a completely different flow of time. Our obsession with radio signals and the search for intelligent life makes us forget that the universe may not be full of intelligence, but simply of life, ancient and incomprehensible. There are hypotheses that life could have originated in the atmosphere of Venus, in the layers of sulfuric acid clouds where the temperature and pressure are more or less acceptable. There, in the perpetual fog, microscopic organisms could float, for whom the entire planet is an endless, inhospitable ocean of clouds. Their world is devoid of a solid surface and a starry sky. It is an eternal twilight in a poisonous haze. Perhaps we are simply looking in the wrong place, searching for life on planets similar to our own, expecting signals like our own. There is a hypothesis that life can exist in completely unimaginable forms, for example in the cold methane seas of Titan, Saturn's largest moon. There, at a temperature of minus 180 degrees Celsius, silicon-based organisms could exist, with methane instead of water in their cells and breathing hydrogen. Their metabolism would be incredibly slow. A single breath could last thousands of Earth years. We are searching for intelligent life, but perhaps right next to us, within the solar system, slumbers a life that perceives time completely differently, and for which all our space missions are just an instantaneous, imperceptible flash of light. This slowness may be the key to many things that seem strange and inexplicable to us in space. Tabby's star, or KIC 8462852, showed such strange and irregular changes in brightness that it did not fit into any known model. Its light dimmed by tens of % for different, unpredictable periods of time, as if something huge and irregularly shaped were orbiting it. The most daring and exciting hypothesis was the assumption of a megastructure built by an advanced civilization, a so-called Dyson sphere, collecting the star's energy. Although scientists now lean towards a more prosaic version involving a cloud of cometary dust, the very possibility that we caught a glimpse of the shadow of an alien engineering genius remains a quiet, thrilling whisper in the astronomical community. This whisper becomes louder and darker when we realize that even if civilizations exist, they may be long dead. The Fermi paradox is not just a childish question of where is everybody? It is a grim suggestion of the existence of a great filter. This could be any stage in the development of life that is almost impossible to overcome. The origin of life itself, the emergence of multicellular organisms, the leap to intelligence, or, most alarmingly, a technological barrier that any sufficiently advanced civilization overcomes by self-destructing. Perhaps space is silent not because it is empty, but because it is a vast graveyard of civilizations that failed their final test. One of these trials could be a collision with an object that we won't even have time to notice. There are so-called potentially hazardous asteroids whose trajectories intersect Earth's orbit. NASA and other agencies track most of them, but the problem is that many of these rocks are very dark, covered in carbonaceous compounds, and reflect less light than a piece of coal. They only become visible when they get too close. This means that somewhere in the darkness right now, a city-sized rock could be hurtling along, its existence unknown to us until a few days or hours before impact, when it will be too late to do anything. But even if we avoid a collision with a rock, space itself can kill us from a distance, without any warning. A gamma ray burst from the merger of two neutron stars or a hypernova explosion is one of the most energetic events in the universe. If such a beam, narrow and incredibly powerful, were to strike Earth, it would instantly destroy the ozone layer, triggering a chain reaction in the atmosphere and a mass extinction of all life on the surface from harsh ultraviolet radiation. We cannot predict where it will come from. It's like living in a shooting gallery where, somewhere in the universe, a trigger is pulled at random, and we can only hope the barrel isn't pointing our way. This cosmic roulette becomes even more frightening when we think about magnetars, the most powerful magnets in the universe. This is a type of neutron star whose magnetic field is quadrillions of times stronger than Earth's. Sometimes, starquakes occur in their crust, releasing a colossal amount of energy in the form of gamma rays. In 2004, a flare from the magnetar SGR 180620, located on the other side of the galaxy, partially ionized the upper layers of Earth's atmosphere. If such an object were within 100 light-years of us, its flare could cause a mass extinction. We live in a galaxy with dormant magnetic monsters capable of striking across the abyss of space. Sometimes the killer doesn't come from afar but is born very close by and moves silently, like a shadow. There are rogue black holes, stellar mass objects that have been ejected from their galaxies by gravitational perturbations and now fly through intergalactic space at hundreds of kilometers per second. They are completely invisible, as they do not actively accrete matter and do not emit light. Such a black hole could pass through the solar system like a ghost, its gravitational field tearing planets from their orbits and sending them either into the icy void or into the sun's embrace. This is a silent and inevitable end of the world that we will not see, but only feel as a final, fatal jolt. There is a theoretical threat even more insidious than a black hole: hypothetical strange matter. This is a form of matter that, according to some theories, may be more stable than ordinary matter. If a tiny piece of such matter, a strangelet, collides with ordinary matter like a star or a planet, it could trigger a chain reaction, converting everything it touches into strange matter. It would not be an explosion, but a quiet, silent rewriting of reality at a fundamental level. The planet would simply cease to be itself, turning into a lifeless, super-dense ball of strange matter. This is an absolute plague that can travel through space, erasing worlds. Even the light of stars, which seems so eternal and serene to us, can carry a hidden danger. High-energy cosmic rays are a stream of protons and atomic nuclei, accelerated to near-light speeds by supernova explosions and active galactic nuclei. They permeate the entire galaxy in a continuous rain. On Earth, we are reliably protected by the atmosphere and magnetic field, but in open space they are like microscopic bullets. A single such puncture can damage an astronaut's DNA, causing cancer, or instantly disable a ship's vital electronics. It is an invisible storm from which it is impossible to hide, a constant reminder of the hostility of the environment beyond our cradle. This hostility also manifests in more insidious, almost tangible forms. For example, on the Moon. Our satellite has no atmosphere to burn up micrometeorites, and its surface is constantly bombarded by tiny particles flying at enormous speeds. Because of this, the lunar dust, regolith, consists of particles as sharp as broken glass, which are also electrically charged and literally hover above the surface. It penetrates everywhere, into the seams of spacesuits, into mechanisms, into the lungs. The Apollo program astronauts complained that it smelled like burnt gunpowder and caused severe irritation. A long-term stay on the Moon would be deadly, not so much because of the radiation, but because of this ubiquitous, abrasive dust that would slowly destroy both equipment and people. The smell of gunpowder is just one note in the strange symphony of space aromas, which is not often talked about. Astronauts, upon returning from the airlock after a spacewalk, describe a distinct smell that lingers on their spacesuits and equipment. This is not the smell of a vacuum, but rather the smell of emptiness itself, having reacted with oxygen. Some describe it as the smell of seared metal, others as the smell of ozone or even burnt steak. This aroma is the result of the interaction of atomic oxygen, which clings to spacesuits in the vacuum, with the station's atmosphere. It is the closest ghost of space to us, one that can not only be seen, but also smelled. Destruction can also come from within, when the human body, finding itself in an unfamiliar environment, begins to rebel against itself. In space, under conditions of weightlessness, fluids in the body redistribute, rushing to the upper torso and head, which causes the face to swell and intracranial pressure to rise. This pressure squeezes the eyeballs from behind, flattening them and deforming the optic nerve, which leads to vision impairment. Many astronauts develop far-sightedness after long missions, and these changes can be irreversible. Space literally changes the way we see the world, and this is a price they don't like to talk about in space tourism brochures. Another silent toll that weightlessness exacts is on our bones and muscles. Without the constant gravitational load, the body decides it no longer needs a strong skeleton and powerful musculature to maintain an upright position. Rapid atrophy begins. Astronauts on the International Space Station lose up to 1 to 2% of their bone mass per month. This is comparable to the rate of severe osteoporosis development in the elderly on Earth. They are forced to exercise for 2 hours a day on special machines, simply to avoid returning to Earth as invalids, unable to stand on their own feet. Space leaches our very support from us, turning the body into a fragile, pliable shell. But the most terrifying thing happens not to the body, but to the mind, trapped in a cramped metal box in the middle of infinity. Prolonged isolation in a confined space, far from all of humanity, under the constant pressure of mortal danger, can lead to serious psychological breakdowns. The phenomenon of space dementia, or the breakaway effect, is what all space agencies secretly fear. Astronauts can fall into deep depression, become unreasonably aggressive, or lose their connection to reality. There are known cases where, during ground-based simulations of long-duration flights, crews stopped communicating with each other for several weeks. What will happen during an actual flight to Mars, no one knows. There is also a more specific, almost mystical disorder known as solipsism syndrome, which is feared by psychologists working with astronauts. It is a condition in which a person in deep isolation begins to doubt the reality of the surrounding world and other people, coming to the belief that it is all merely a figment of their imagination. Imagine an astronaut who, looking out the porthole at the distant Earth, suddenly decides that neither Earth nor their crewmates actually exist. This is the ultimate form of loneliness, when a person loses not only their connection to home, but to reality itself. It is a silent horror that is not written about in reports. This breakaway effect also has another, more philosophical and brighter side, known as the overview effect. Seeing the Earth from space, a small, fragile blue marble floating in the velvety blackness without visible borders or nations, many astronauts experience a profound existential epiphany, a feeling of unity with all of humanity. But it also has a dark side. Some begin to feel completely detached from humanity, from its petty worries and trivial problems. Upon returning, they cannot adapt to their former lives. The dazzling beauty of space makes earthly reality seem dull and meaningless. It is a quiet tragedy that is not written about in heroic biographies. Sometimes, space sends us objects that call into question our very understanding of what is normal for the universe. Oumuamua, the first recorded interstellar object to pass through our solar system in 2017, had a strange, elongated shape like a cigar or a pancake, and moved with a slight acceleration that could not be explained by the sun's gravity alone. It did not leave a gas tail behind it like a comet. One hypothesis, albeit a marginal one, put forward by astrophysicist Avi Loeb, suggested that it could have been an artificial object, perhaps an alien probe or a solar sail. We observed it for too short a time, and it flew away forever, leaving behind more questions than answers. And what if such wandering objects are not the exception, but the rule, and entire star systems can be exiles? There are hypervelocity stars that fly through the galaxy at a speed sufficient to escape its gravitational pull forever. It is believed that they were ejected from the galactic center by the supermassive black hole Sagittarius A, which acts like a giant gravitational slingshot. Imagine a rogue star flying alone through the icy intergalactic void, pulling its planets along with it if they survived such a cataclysm. Entire worlds doomed to an eternal journey in darkness without their galactic home and stellar neighbors. This is the ultimate form of cosmic loneliness. Loneliness can be the fate not only of stars, but of entire galaxies. There are so-called void galaxies, stellar islands that for some reason formed not in the dense clusters and filaments of the cosmic web, but in giant cosmic voids where there is practically no matter. For the hypothetical inhabitants of such a galaxy, the night sky would be almost completely black. They would not see the Milky Way, they would not see neighboring galaxies like Andromeda. Their entire cosmology would be built on the idea that their galaxy is the only thing that exists in the universe. It is a frightening thought about how our knowledge and our very sense of the world are limited by the horizon of our view. This horizon is constantly expanding thanks to new telescopes, but the universe itself is expanding even faster. Due to the accelerated expansion caused by mysterious dark energy, galaxies that are beyond a certain limit, the so-called event horizon, are moving away from us at a speed exceeding the speed of light. This means that their light will never reach us, and we will never know of their existence. We are locked in our cosmic bubble, and over time, in trillions of years, all galaxies beyond our local group will disappear from view. Future civilizations will see a completely empty sky, and perhaps will never know that the universe was once full of stellar islands. Dark energy, which causes this acceleration and tears the fabric of space, is one of the greatest mysteries of modern physics. It makes up almost 70% of all energy in the universe, but we have no idea what it is. It is a kind of anti-gravitational force inherent to the vacuum itself, the energy of emptiness. And the most alarming thing is that we do not know if it is constant. If its density increases over time, it could lead to the Big Rip scenario. This force would tear apart first galaxy clusters, then the galaxies themselves, then stars and planets, and finally, molecules and atoms themselves. The universe would simply disintegrate into unbound particles, and this would be a finale that is impossible even to imagine. Another mysterious substance, dark matter, makes up about 25% of the universe's mass and serves as an invisible glue that keeps galaxies from flying apart. We know it exists because we see its gravitational influence on the movement of stars and light, but we cannot see or touch it. It does not interact with light or ordinary matter. Right now, as you listen to this, billions of dark matter particles are passing through your body, but you do not feel it. We live in a ghostly world that is 5 times more massive than what we can see, as if in a house full of invisible inhabitants with whom it is impossible to communicate. The search for this matter is being conducted in the deepest mines underground, in special laboratories, to shield ultra-sensitive detectors from the stream of ordinary cosmic rays. But decades of searching have yielded no definitive result, not a single captured particle. This leads some scientists to doubt. Does dark matter even exist? Perhaps we simply misunderstand the laws of gravity on large scales, and Einstein's general theory of relativity needs modification. This is an uncomfortable thought because it means that all of modern cosmology could be built on a faulty foundation. It is easier to believe in an invisible substance than to admit that we might be fundamentally wrong. Mistakes in space are costly, and the history of cosmonautics is filled not only with triumphs, but also with quiet failures hidden from the public. The Soviet lunar program, for example, did not officially exist until the era of glasnost. But it did exist, and the giant N-1 rocket, which was supposed to deliver Soviet cosmonauts to the moon, exploded 4 times in a row during test launches. One of the explosions in 1969 was one of the most powerful non-nuclear explosions in human history. It completely destroyed the launch complex. These disasters were classified for decades, creating a myth of the Soviet space program's flawlessness and infallibility. This secrecy also gave rise to darker legends that still stir the imagination. These are the lost cosmonauts, hypothetical Soviet pilots who allegedly died in space before Yuri Gagarin's flight, but whose deaths were concealed by the authorities so as not to tarnish the country's image. Although there is no serious evidence for this, There are eerie audio recordings made by Italian radio amateurs in the 60s, on which, it is claimed, one can hear the last words and even the death screams of unknown cosmonauts. Whether this is truth or a hoax, we may never know, but this legend remains a dark shadow, a ghost hovering over the dawn of the space age. The American Apollo program also had its skeletons in the closet, moments when everything hung by a thread. During the Apollo 10 mission, which was the dress rehearsal for the moon landing, the lunar module, while in orbit around the satellite, began to spin uncontrollably due to a pilot error and an incorrect switch position. In the declassified transcripts of the communications, one can hear the astronauts' profanity and panic as they lost control of the situation for a few agonizing moments. Had they not been able to regain it, they would have inevitably crashed onto the lunar surface. The public was informed of this incident in a very smoothed-over and vague manner. Even after a successful return to Earth, it wasn't just honors and parades that awaited the astronauts. After the historic Apollo 11 flight, Neil Armstrong, Buzz Aldrin, and Michael Collins were placed in a strict 3-week quarantine in a special van. NASA seriously feared that they might have brought back unknown microorganisms from the moon, a lunar plague capable of destroying life on Earth. The probability of this was negligible, but not zero. This almost forgotten fact underscores how little we know about other worlds and what unpredictable risks their exploration entails. We search for life, but at the same time, we are terrified of finding it. This fear forces us to be extremely cautious, almost paranoid. All spacecraft sent to Mars or other potentially habitable worlds, like Jupiter's moon Europa, undergo the strictest sterilization in special, clean rooms. This is done not only to avoid contaminating our scientific experiments for finding life with terrestrial bacteria, but also because of the ethical principle of planetary protection. We are afraid of introducing hardy terrestrial microbes to Mars that could displace or destroy hypothetical native life if it exists there. Ironically, we could become the very evil aliens from science fiction films without intending to. Sometimes we ourselves create the danger that threatens our future in space. Space debris is one of the most serious and underestimated problems of our time. Tens of thousands of spent rocket stages, dead satellites, and millions of small fragments of paint and metal orbit the Earth at tremendous speeds, up to 28,000 kilometers per hour. A collision with an object just a few centimeters in size can destroy an active satellite or puncture the hull of the ISS. There is a theoretical possibility of the Kessler syndrome, a chain reaction where collisions begin to generate more and more debris, until low Earth orbit becomes completely unusable for flight for hundreds of years. We risk trapping ourselves on our own planet. The International Space Station, that shining symbol of international cooperation, is in fact an incredibly fragile and vulnerable structure. It constantly needs its orbit corrected, using the engines of cargo ships to keep from falling to Earth. It regularly experiences microscopic air leaks, life support system failures, and false fire alarms. Astronauts live in a state of constant readiness for emergency evacuation to the docked Soyuz spacecraft. We admire the views from the ISS, but we don't think about the fact that its inhabitants live on a technological powder keg, where the price of a single mistake or one successful debris impact is the life of the entire crew. Inside this powder keg reigns its own special world of sounds, one that never falls silent. It is not the silence of space, but the constant monotonous hum of life support systems, fans, pumps, filters. This noise, comparable in volume to a running vacuum cleaner, follows the astronauts 24 hours a day. It has become so familiar that the complete silence that occurs during rare failures causes panic among the crew, as it means something vital has stopped working. This continuous hum is the soundtrack to the fragile human presence in a deadly environment, a lullaby of survival. This fragility extends to our dreams of a future in space. The flight to Mars, so much talked about, involves a radiation risk that NASA and other agencies try not to publicize. The radiation environment in interplanetary space, filled with galactic rays and solar protons, is such that during a round trip, astronauts would receive a radiation dose close to the maximum permissible for their entire career. This significantly increases the risk of cancer and damage to the central nervous system. In essence, the first Martian colonists will have a one-way ticket, not only due to the technical difficulties of returning, but also because of the consequences for their health. And even if they reach the red planet, they will find an unfriendly and toxic world. The atmosphere of Mars is 95% carbon dioxide and is so thin that the surface pressure is comparable to the pressure on Earth at an altitude of 35 kilometers. Water on the surface boils instantly, even at low temperatures. And the Martian soil, as discovered by the Phoenix lander, contains perchlorates, toxic substances that make it poisonous to many terrestrial plants and possibly to humans. The idea of terraforming and creating a second home runs into fundamental chemical and physical obstacles that make this dream almost unattainable in the foreseeable future. But what if there are worlds inherently more habitable than Mars? Planets around red dwarfs, the most common and longest living stars in the galaxy, were long considered prime candidates for this role. But they have their dark side. Red dwarfs are very unstable in their youth and are prone to powerful flares that can strip the atmosphere from nearby planets. Furthermore, planets in the habitable zone of such dim stars must be very close to them and would likely be tidally locked, one side always facing the star and the other in perpetual icy night. This would create a world with one scorching desert and one icy wasteland. Such eyeball planets are not science fiction, but a quite probable and common reality in the universe. On the border between the day and night sides, in the zone of perpetual twilight where the temperature could be suitable, life could theoretically exist. But it would be a strange, motionless world where the sun never rises or sets, but is frozen in a single point in the sky. It is a world without the change of day and night, without the rhythms familiar to us. What would intelligence born in such conditions be like? What myths and what science would it create, gazing at a motionless sky? There are also even more exotic and inhospitable worlds that challenge our imagination. The planet 55 Cancri A, orbiting very close to its star, is hypothesized to be composed mainly of carbon, and under the immense pressure and temperature on its surface, this carbon could have turned into diamond. This is a diamond planet, a world where mountains could be made of pure diamond and the rain could be of graphite. It sounds beautiful and fantastical, but for life as we know it, such a world would be a living hell. The absence of water and oxygen and the extreme conditions make it simply a dead, albeit incredibly expensive, rock shining in the void. Another extreme is ocean planets, hypothetical worlds completely covered by water, hundreds or even thousands of kilometers deep. On such planets, there is no land, not a single patch of Earth. Life could well have originated in these bottomless depths near hydrothermal vents, but it would be practically impossible for it to develop technology. Without access to metals, which are hidden under an immense body of water, without the ability to make fire, a civilization of intelligent aquatic beings would forever remain trapped in its aquatic world, unable to even know of the existence of the stars and galaxies overhead. Sometimes the greatest strangeness and dangers are not hidden in distant exotic worlds, but in the very heart of our own system. The sun, our life-giving star, is not as stable and calm as it seems. Once every few centuries, it experiences superflares that cause massive geomagnetic storms on Earth. The Carrington event in 1859 caused the failure of telegraph networks worldwide, which began to shock operators, and auroras visible even in Cuba. If such a storm were to occur today, it could disable most satellites and power grids on the planet, throwing our civilization back decades in a matter of hours. We live in complete dependence on the mood of our star. And this mood is frighteningly unpredictable. We still do not fully understand the mechanisms that govern the 11-year cycle of solar activity. Sometimes the cycles almost disappear, as happened during the Maunder Minimum in the 17th century, which strangely coincided with the Little Ice Age in Europe. Sometimes they are, on the contrary, abnormally active, threatening our technosphere. Our dependence on the sun is absolute, but our understanding of its behavior is alarmingly incomplete. We live next to a giant thermonuclear reactor, the instructions for which we have not yet fully read, and which sometimes does not play by the rules. Its unpredictability is also manifested in phenomena such as coronal rain. This is one of the most mesmerizing and simultaneously frightening spectacles on the sun. Giant loops of incandescent plasma, lifted by magnetic fields for hundreds of thousands of kilometers, cool and fall back onto the star's surface in the form of a fiery shower. Each drop of this rain exceeds the Earth in size. This seemingly quiet and graceful phenomenon conceals unimaginable power and temperatures of millions of degrees, reminding us of the raging element hidden behind the familiar solar disk. This lack of understanding extends to other, seemingly well-studied objects in the solar system. For example, the axial tilt of Uranus is 98 degrees. It rotates literally lying on its side, and its poles alternately face the sun directly for decades. This leads to extreme seasons, each lasting 21 Earth years. It is believed that in the distant past, at the dawn of the solar system's formation, Uranus collided with an Earth-sized object that literally knocked it off its feet. This is a reminder that the history of our system was turbulent and chaotic, and our current calm is merely a temporary respite. This chaos is still present in the system, lurking in the shadows of the planets. The asteroid belt between Mars and Jupiter is not the remains of a destroyed planet, as was previously thought, but a failed planet that was prevented from forming by the powerful gravity of the giant Jupiter. It constantly stirs the asteroids like a spoon in a cup, sometimes flinging them onto trajectories that cross the orbits of the inner planets, including Earth. Jupiter is our main protector, attracting and absorbing many comets and asteroids flying in from the outside, but it is also a source of potential threat, an unpredictable conductor in this gravitational orchestra. Jupiter itself holds the secret of its youth. It still radiates almost twice as much heat as it receives from the sun. This excess heat is the residual energy from its formation 4.5 billion years ago. The planet is slowly cooling and contracting, like a fading ember of a giant cosmic fire. This internal heat of its own fuels its furious storms and creates the most complex weather system in the solar system, including the famous Great Red Spot. Jupiter is not just a cold gas giant, but a living, heat-breathing world whose heart has not yet cooled. There are also more subtle, almost mystical phenomena that have long stumped scientists. The Pioneer effect is the unexplained and anomalous deceleration of the Pioneer 10 and Pioneer 11 space probes as they were leaving the solar system. They were slowing down slightly more than gravitational theory predicted, as if something were holding them back by the tail. For decades, this was considered an anomaly, hinting at new physics. Although a recent analysis showed that the cause was most likely asymmetric thermal radiation from the probes themselves, This story left a deep scar on the confidence of scientists in the completeness of their models. The universe always finds a way to surprise us. Objects that we created ourselves and then forgot are also surprising. Black Knight is the name given in conspiracy circles to an unidentified object in near-Earth orbit that was allegedly observed even before the launch of the first artificial satellite. This is a popular conspiracy theory, but it has a real basis. There are indeed objects in space that are difficult to identify. For example, a thermal blanket lost by astronaut Ed White during the Gemini 4 mission was long mistaken for an unknown satellite. Our orbit is full of our own ghosts and lost things that have become space debris. One such ghost is the Vanguard 1 satellite, launched by the USA in 1958. It is the oldest artificial object still in Earth's orbit. It has long been non-functional, having turned into a dead piece of metal, but it continues to circle the planet, completing one orbit every 134 minutes. Its estimated orbital lifespan is about 2,000 years. It will outlive all of us and perhaps our entire civilization, remaining a silent monument to the dawn of the space age, rotating slowly and alone in the void. Sometimes we lose contact with our creations forever, and they die alone millions of kilometers from home. The Spirit rover fell silent in 2010, stuck in a sand trap in Gusev crater. Its last messages transmitted to Earth were full of desperation. It was trying with its last strength to turn its solar panels toward the fading winter Martian sun to get at least a little energy. The last futile attempt to contact it was made in May 2011. Since then, it has been silent. Somewhere on the surface of Mars stands a robot covered in red dust, which once transmitted amazing panoramas of another world to us and has now become part of its silent landscape. This piercing melancholy permeates the entire history of space exploration. The Voyager 1 probe, which has already left the solar system and is flying through interstellar space, carries a golden record with sounds and images of Earth as a message for extraterrestrial civilizations. But the probability of it being found by anyone in the boundless ocean of space is vanishingly small. It flies into the void, and only in 40,000 years will it approach another star. This is not so much a message as an epitaph, a cry into the void, which says more about our own loneliness than about a real desire to make contact. The very concept of contact can be extremely dangerous, and some scientists caution against excessive enthusiasm. The late Stephen Hawking warned that actively sending signals into space through projects like METI, messaging to extraterrestrial intelligence, could be reckless. If there are predatory civilizations in space, we are, in essence, shouting in a dark forest, giving away our location. An encounter with a more advanced civilization could end for us just as the encounter with Columbus ended for the Native Americans. The silence of space may not be a sign of the absence of life, but a sign of its wisdom and caution. Wisdom can also lie in understanding that some things are better left untouched, even if they are within our reach. On Mars, there are regions that NASA classifies as special regions. These are places where liquid water could theoretically exist, for example, in subsurface layers, and consequently, modern Martian life. It is strictly forbidden to send rovers there, so as not to accidentally introduce terrestrial microbes and disrupt a potential biosphere. We stand on the threshold of the greatest discovery in human history, yet we are afraid to take the final step, bound by our own ethical principles. This fear is well-founded. If we find life on Mars, even the most primitive microbial life, and prove that it originated independently of Earth's, it would mean that life is a common and widespread phenomenon in the universe. And then the Fermi paradox, the question, where is everybody, would sound even more ominous. If life arises everywhere with relative ease, yet no one makes contact or colonizes the galaxy, it means that the great filter that destroys civilizations is not in our past, but with high probability in our immediate future. Perhaps this final filter is not war or ecological disaster, but the very nature of physical reality. There is the false vacuum hypothesis. Our universe may not be in a truly stable state, but in a metastable one, like a ball resting not at the bottom of a valley, but in a small dip on a hillside. If somewhere in the universe, due to a random fluctuation, the vacuum spontaneously transitions to a lower, true energy state, this transition would begin to expand like a bubble at the speed of light, destroying everything in its path and changing the fundamental laws of physics. We would never see it coming. The universe could simply switch to another state at any moment. This fundamental fragility of existence makes one ponder the nature of our own consciousness. The Boltzmann brain is a disturbing thought experiment that takes the idea of random fluctuations in an eternal universe to its absurd conclusion. In a sufficiently large and old universe, according to statistical mechanics, the spontaneous emergence from chaos of a lone, self-aware brain with a complete set of false memories about life and the universe is more probable than the emergence of the entire ordered universe we observe. This leads to a frightening solipsistic conclusion. It is statistically more likely that you are such a brain that has just dreamed up the entire world than that the world is real. Reality can be an illusion in another, no less profound sense. The holographic principle, which arose from the study of black hole thermodynamics and string theory, suggests that all the information about the three-dimensional space we live in could be recorded on a two-dimensional surface at the boundary of the observable universe, like a hologram. We might be just a projection, a complex shadow cast upon the cosmic horizon. This is not just a crazy idea. It has serious mathematical foundations and is one of the most discussed topics in theoretical physics. Our solid, tangible reality might turn out to be just a complex illusion. This idea resonates with another, even more unsettling hypothesis, the simulation hypothesis. If we assume that any sufficiently advanced civilization will sooner or later learn to create simulations of reality indistinguishable from the real thing, then it is statistically almost inevitable that the number of simulated realities will be many orders of magnitude greater than the one single, base reality. Therefore, the probability that we are living in one of these simulations rather than in the real world approaches 1. Our laws of physics might simply be the rules of a software code, and the creators of this world could press pause or exit at any moment. And even if our world is real, it may be far from the only one. The theory of inflation, which describes the first moments after the Big Bang, almost inevitably leads to the idea of a multiverse, the existence of an infinite number of parallel worlds or bubbles in which different laws of physics or different outcomes of random quantum events can be realized. Somewhere there is a universe where you made a different decision this morning. Somewhere there is a universe where the dinosaurs did not go extinct. This idea, on the one hand, is breathtaking, and on the other, it devalues the uniqueness of our existence, turning it into one of infinite random variations in a cosmic foam. In our own universe, there are also things that do not behave as they should, hinting that there is something we do not understand. The axis of evil is the unofficial, provocative name for an anomaly in the cosmic microwave background radiation left over from the Big Bang. This radiation, which fills the entire universe, is not completely random and isotropic as the standard cosmological model predicts. It contains a preferred axis around which temperature fluctuations are aligned in a strange, ordered way. And this axis inexplicably aligns with the ecliptic plane of the solar system. This is either an incredible coincidence or a hint that our solar system occupies some special place in the universe, which contradicts the fundamental Copernican principle. Another large-scale anomaly is the Great Attractor. It is a gravitational anomaly in intergalactic space in the direction of the constellations Norma and Ara, which is pulling our Milky Way galaxy, the Virgo supercluster, and hundreds of thousands of other galaxies toward it. We cannot see what it is because it is hidden from us behind a dense veil of dust and stars in the plane of our own galaxy. It could be a gigantic supercluster of galaxies or something else entirely, even more massive. We are all flying together at a speed of hundreds of kilometers per second towards something enormous and invisible, like moths to a light whose source is hidden. But this flight does not pass through emptiness. It follows invisible threads woven from the universe's very dark matter. The large-scale structure of the universe, as shown by computer simulations and observations, resembles a giant three-dimensional cosmic web. Galaxies and galaxy clusters are located along long threads, filaments, and at their intersection points are massive clusters. Between these threads stretch giant voids, where there is almost nothing. We do not just live in the universe, we live in its circulatory system, in a cosmic network whose nature and architecture we are only beginning to comprehend. Sometimes abnormally cold and empty regions are found in this network. The CMB cold spot in the constellation Eridanus is a huge area in the sky that is significantly colder than the surrounding cosmic microwave background radiation. One hypothesis states that it is the imprint of a giant supervoid, almost devoid of both ordinary and dark matter, which stretched the photons of the cosmic microwave background radiation, causing them to lose energy. But there is also a more exotic and bold theory. It is a bruise left over from the collision of our universe with another parallel universe in the distant past. There is an even more grandiose void, the Bootes void in the constellation Botes. This is a colossal, almost spherical region of space, about 330 million light-years in diameter, containing only a few dozen galaxies, whereas there should have been several thousand. It is one of the largest and emptiest structures in the entire observable universe. To look in its direction is to look into the face of almost absolute nothingness. The existence of such giant holes in the fabric of the cosmos does not align well with our models of universe formation and reminds us that even emptiness can be anomalous and mysterious. Even time, which we are accustomed to considering absolute and unchanging, behaves strangely and malleably in space. According to Einstein's general theory of relativity, time flows more slowly near massive objects due to the curvature of space-time. For GPS satellites in high orbit, constant corrections must be made because their clocks run fractions of a second faster than on Earth. And for a hypothetical observer on the surface of a neutron star, time would slow almost to a complete stop compared to on Earth. The concept of now loses all meaning on a cosmic scale. Every object in the universe has its own time. This means that the past and future are also relative. For a photon, a particle of light traveling at the speed of light, time does not exist at all. For it, the moment of its emission by a star and the moment of its absorption by your eye are one and the same instant, even if billions of years and light years have passed between these two events. The entire history of the universe is compressed into a single point for it. This calls into question our intuitive, linear perception of time as something immutable and universal, flowing from the past into the future. Sometimes the cosmos sends us greetings from the very distant past, allowing us to glimpse its youth. Quasars are extremely bright and active nuclei of young galaxies, whose light has traveled for billions of years to reach us. At their center are supermassive black holes, greedily consuming matter and ejecting powerful jets. When we look at a distant quasar, we see the universe as it was in its turbulent youth. These are true time machines that show us the eras when stars were just beginning to form. But it is also a reminder that we always see only the past. What the universe is like now, we will never know. But what if the past could not only be seen, but also changed? The idea of closed, time-like curves or time machines does not theoretically contradict the general theory of relativity. Although their creation likely requires exotic matter with negative energy, which we have never observed, the very possibility of their existence gives rise to unsolvable logical paradoxes, like the famous grandfather paradox. Some physicists, including Stephen Hawking, believe that the universe has a built-in chronology protection principle that forbids such paradoxes, but no one knows exactly how it works. This cosmic censorship might manifest itself as the event horizon of black holes. This is the point of no return, a boundary from which not even light can escape, and therefore no information. What happens inside? We do not know and will never know. Theory predicts a singularity there, a point of infinite density and zero volume, where all the laws of physics as we know them cease to work. The event horizon is perhaps the very mechanism that politely hides this glitch in the fabric of reality from us, protecting the rest of the universe from the consequences of causality violations. But Stephen Hawking himself showed that black holes are not entirely black and not eternal. Due to quantum effects at the very event horizon, they slowly evaporate, emitting so-called Hawking radiation. This process is incredibly slow for large black holes, but it leads to the profound information paradox. Information about what has fallen into a black hole, according to quantum mechanics, cannot disappear without a trace. But in the process of evaporation, it seemingly gets erased forever. Where does the soul of a star that has fallen into a black hole go? This question remains unsolved and is at the forefront of theoretical physics. Perhaps the answer lies in the even bolder idea that black holes are not endings, but beginnings. Some theories suggest that a new daughter universe could be born inside a black hole. Matter falling into a black hole is compressed to a singularity and then bounces back, giving birth to its own Big Bang in a separate space-time. Our own universe may have also been born from a singularity inside a black hole in some other parent meta-universe. We might be just one of an infinite number of children in the cosmic tree of worlds. These ideas take us far beyond the bounds of verifiable science, into the realm of pure metaphysics and philosophy. But even in more down-to-earth familiar things, the cosmos is full of strangeness and anomalies. For example, Venus, our neighbor, rotates in the opposite direction compared to most planets in the solar system, and its day, 243 Earth days, is longer than its year, 225 Earth days. And Saturn, the ringed giant, has such a low average density that if a large enough ocean existed, Saturn would float in it like a bobber. These facts are not threats, but they quietly remind us that no two worlds in the solar system are the same, and each is a unique anomaly with its own history. At the North Pole of this floating giant rages one of the strangest storms in the solar system. It is a gigantic, perfectly regular hexagon, with each side larger than the diameter of the Earth. This hexagon is a stable atmospheric vortex that has been rotating with the planet for decades, perhaps even hundreds of years. Scientists still do not fully understand why it has this particular shape. It is an example of how simple laws of hydrodynamics under exotic conditions can give rise to almost artificial, mathematically perfect geometry, frightening in its regularity. Saturn's moons are no less mysterious. Iapetus, for example, is a world of two extremes. One of its hemispheres is as bright as freshly fallen snow, while the other is as dark as asphalt. In addition, a giant mountain range up to 20 kilometers high runs along its equator, giving it the appearance of a walnut. No one knows for sure how this ridge formed or why Iapetus is so strangely colored. It remains a silent reproach to our desire to classify and explain everything, a quiet monument to the incomprehensible complexity of the cosmos. The moon, our closest and seemingly most studied neighbor, is also full of mysteries and quiet processes. It is slowly but surely moving away from the Earth at a rate of about 4 centimeters per year due to tidal interaction. This means that in the distant past it was much closer to the Earth, appeared enormous in the sky, and the ocean tides were gigantic, possibly playing a role in the emergence of life on land. And in the distant future, total solar eclipses will cease, as the moon's apparent disk will become too small to completely cover the sun. We live in a brief and unique astronomical moment when this perfect celestial wonder is possible. Sometimes on this seemingly dead moon, transient lunar phenomena are observed, mysterious flashes of light, localized hazes, or changes in the color of surface areas. Their nature is not fully understood. They could be gas emissions from the moon's interior, which has not yet completely cooled, meteorite impacts, or simply optical illusions in the Earth's atmosphere. But for centuries, astronomers, both professional and amateur, have reported these strange lights on the moon, which live their own life, incomprehensible to us, on the silent face of our satellite. Far beyond the orbit of Neptune, in the icy expanses of the Kuiper Belt, lurk objects that behave very strangely. For example, the dwarf planet Sedna has an incredibly elongated and distant orbit that is difficult to explain by interactions with the known planets of the solar system. This and other similar orbits have given rise to the hypothesis of a ninth planet, Planet X, a massive body the size of Neptune, whose gravity influences these distant worlds. The search for this planet is being conducted worldwide, but so far without success. Somewhere on the dark outskirts of our system, a whole world we do not yet know about may be hiding. There, on the outskirts, lies another mystery, Triton, Neptune's largest moon. It is unique in that it revolves around its planet in the opposite direction, against its rotation. This almost certainly means that it did not form with Neptune, but was captured by its gravity, having arrived from the Kuiper Belt. This capture must have been a catastrophic event that melted Triton's interior and gave rise to its strange geology. Ice volcanoes erupting nitrogen and cantaloupe terrain, a unique relief found nowhere else. Triton is a captive whose turbulent history is frozen on its icy face. Sometimes we find things that, it would seem, should not exist, objects that break our stereotypes. In 2012, the Hubble Space Telescope discovered asteroid P2013P5, which had 6 tails, making it look like a rotating lawn sprinkler. It turned out not to be a comet, but an asteroid that had begun to disintegrate under the force of its own rapid rotation, spun up by sunlight. This unique object shows that the line between asteroids and comets is very blurred, and there is always a place in the universe for hybrids and oddities that do not fit into our simple classifications. These classifications often prevent us from seeing a complete, deep picture of the world. We divide the cosmos into planets, stars, galaxies, but all of this is just different forms of existence of the same matter, born in the fire of the Big Bang almost 14 billion years ago. The hydrogen in the water you drink, the iron in your blood, the carbon in every cell of your body. All these elements, except for the very lightest, were once created in the cores of stars that lived their lives and exploded billions of years ago. We are literally made of stardust. This is not just a beautiful metaphor, but a strict scientific fact that connects us to the cosmos. But this profound and poetic fact also has its dark, cruel side. The process that creates the heavy elements necessary for life, a supernova explosion, is one of the most destructive and catastrophic events in the universe. To create the gold for your ring or the iodine for your thyroid gland, a massive star had to die in its death throes, ejecting its innards into space at speeds of thousands of kilometers per second. Life and beauty in our universe are born from death and destruction. This is a fundamental law we prefer not to think about when looking at the stars. When thinking about space, we often imagine dazzling pictures from the Hubble telescope, full of bright, saturated colors. But most of these colors are artificial. They are invisible to the human eye. Scientists color the images taken in different filters, ultraviolet, infrared, assigning different colors to different chemical elements or wavelengths to make the structure of nebulae more understandable and visual. Real space, to our vision, would be much dimmer, paler, and more monochromatic. We ourselves create the dazzling beauty that we so admire. Sometimes this artificial beauty hides a terrible and cruel truth. The Tadpole Nebula in the constellation Auriga looks like a group of charming tadpoles swimming towards a bright star cluster. But in reality, they are dense clumps of gas within which protostars are forming, and they are being blasted by powerful stellar wind and radiation from neighboring giant stars. This wind strips away their gaseous envelopes from which planetary systems could have formed. We are not observing the birth of worlds, but their abortion at the earliest stage, a cosmic tragedy broadcast live. There are also vampire stars, or as astronomers call them, blue stragglers. These are old stars in globular clusters that appear abnormally young, blue and hot, even though they should have long since cooled and turned red. It is believed that they rejuvenate themselves by pulling matter from a companion star in a close binary system. They literally suck the life and hydrogen from their neighbor to extend their own stellar life. This is a silent and cruel drama playing out on a scale that is hard to imagine. It is also hard to imagine that our home galaxy is not eternal and that a grand transformation awaits it. In about 5 billion years, the Milky Way will collide with the neighboring Andromeda galaxy, which is already hurtling towards us at a speed of over 100 kilometers per second. Although direct collisions of individual stars will be very rare due to the vast distances between them, gravitational forces will completely change the structure of both galaxies, merging them into one giant elliptical galaxy, which astronomers jokingly call Milkomeda. Our night sky will change beyond recognition. But we will most likely not see this. Around the same time, in 5 billion years, our sun will exhaust the hydrogen reserves in its core and begin to turn into a red giant. It will swell to enormous sizes, engulfing Mercury, Venus, and, with high probability, Earth. Our planet will either burn up in the sun's incandescent atmosphere, or, if it survives in a more distant orbit, will turn into a scorched, lifeless ball of molten rock. The end of the world for humanity, if it still exists, will not come from an asteroid or a nuclear war, but will be dictated by the natural life cycle of our own star. And even if humanity manages to relocate to another star system, an inevitable end awaits its distant descendants. The era of stars in the universe, the era of light, will not last forever. In trillions of years, the last red dwarfs will burn out and turn into cold white dwarfs, neutron stars, and black holes. The universe will plunge into eternal darkness and cold. This will be the degenerate era, when the only sources of energy will be the rare collisions of dead stars and the slow decay of protons, if that is even possible. Then, in an even more unimaginably distant future, the black hole era will begin. Over inconceivably long periods of time, even dead stars and planets will be swallowed by black holes or ejected into the intergalactic void. And the black holes themselves, these last massive objects, will slowly evaporate due to Hawking radiation. This process will take Google's 10 to the 100th power of years, but it too will one day end, and the last black holes will disappear in a flash of light. And at the very end, when the last black hole has vanished, the era of eternal darkness will arrive. The universe will be a cooling, ever-expanding soup of elementary particles, photons with enormous wavelengths, and neutrinos. No structures, no complexity, no information, no life. Only absolute cold, emptiness, and eternal, unbreakable silence. This is the heat death of the universe, its final and inevitable end, predicted by the laws of thermodynamics. This finale, it would seem, devalues all our aspirations, all our history and culture, but at the same time it gives them an incredible poignancy and value. The knowledge that everything is finite makes every moment, every thought, every breath inexpressibly precious. We live in the brief, bright springtime of the universe, in its stelliferous era, in that fleeting moment when stars, planets, and consciousness capable of admiring and being horrified by it all are possible. Even the most unsettling and forbidden facts about space are not a reason for fear or despair. They are a reason for deep humility. They remind us of our true place in the cosmos. We are but a tiny, fleeting spark of reason on a speck of dust, lost in an incomprehensible and largely indifferent infinity. And in this realization, there is its own quiet and profound, almost meditative beauty. Sometimes, looking at the stars, we are not so much searching for answers as for the right questions. And the main question that the cosmos silently asks us is not, are we alone in the universe? But what will we do with our brief moment of light before the eternal night falls? The answer to this question is something each of us must find, not in the eyepieces of telescopes, but deep within ourselves, in the silence of our own hearts. Perhaps the greatest mystery of the cosmos is not dark matter or black holes, not distant galaxies or exotic worlds. It is the very existence of consciousness here, on this planet, a consciousness capable of asking these questions, of feeling awe and wonder while looking at the night sky. The universe, through us, is trying to know itself, and in this sense, each of us is the center of our own universe, a silent observer on the edge of the abyss who has been given the incredible fortune to see it all. These quiet truths of the cosmos, its cold grandeur and frightening mysteries, should not disturb your sleep. On the contrary, they can be a cradle. They show how small our daily worries are in comparison to eternity, and how precious this moment of peace is that we can afford ourselves. The universe will continue its slow, indifferent motion while we rest. If you enjoy these quiet journeys, I invite you to leave a like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Allow your eyes to grow heavy and let the quiet whispers of the cosmos lull your thoughts. Good night.